Unit 5, Lesson 1, Investigation 4. Using the quadratic formula, begin by solving these two equations, finding what the x's equal. It's 2x and 1x, right? 2 times negative 6 plus 1 times 2 and c equals negative 5. That's what's the order. Any question? Is there any combinations of these that'll add to 5? Is there any combinations of these that'll add to 5? That add to 5?
I don't know if there's
X times 1, X times 3. What is it always going to be? X times 3 is always going to be 4, right? Was it? 1 plus 3 is 4, not 5.
You got that one right here though. X times 1 is 1. Plus 1 plus 3.
No, you don't add them. It's 1 x 1 times 1 plus 1 times 3. We'll go through it. Alright guys. So we're trying to solve these, so we're trying to find the x values that make the equations true, right? Now yesterday, how did we solve these? What did we do? We factored it, right?
Yes. So
to factor this first one, we write down the factors of 2x squared and
12.
negative 12. Make sure it's negative, right?
Yes.
Factors of 2x squared are 2x and x. Factors of negative 12 are negative 6 and 2. Negative 2, 6. Negative 3, 4. Negative 4, 3. Negative 12, 1. Negative 1, 12. Okay, so those are our factors of negative 12, right?
Yes.
Okay, so now we got to find the combination that adds to what? Negative 5. We got to find the combination that adds to negative 5. So, those of you that have done this, which one should I start with? Negative 4 and 3. So if I do 2 times 2x times negative 4 plus x times 3, 2 times negative 4 is what? Negative 8. X times 3 is 3. Negative 8 plus 3 is? Negative 5. So this one works, doesn't it?
Yes.
Now you could have tried the rest of these, but that's the only one that works. So now to write our factors, we drop down our x's, cross over our c's, and those are our factors, right?
No.
Now is this done?
No.
No, it's not a factor, it's solved, isn't it? So now to find our x's, what do I do with each factor? Set them equal to 0. So 2x plus 3 equals 0, and x minus 4 equals 0. How do I solve this one? Add 4. So x equals 4. Good. How do I solve this one? Minus 3. We have 2x equals negative 3. Now what? Divide by 2. Negative 1.5, right?
Yeah.
So then our two solutions are negative 1.5, and 4. So what does that mean for this equation? For this equation, because 2x squared minus 5x minus 12, that's a parabola, right? What is this, the fact that when that equals 0 are these two x's, what does that mean for the parabola? Doug?
You can plug any, or either the two x's into the equation.
Okay, so I plug these into the equation, I'll get 0. But what does that mean for the parabola made by the equation? It's where they cross which one? The x-axis, good. These x's are where this parabola crosses the x-axis, right? Right? Okay. Bracket for question? What's the question?
Why didn't you divide
Why did I divide this one? Because there's nothing in front of the x. Okay? Alright. So, these x's are where that parabola crosses the x-axis. Right? You guys agree with me? Yeah? Alright. I found this cool piece of software online. Alright. I posted a link to my Facebook. Alright. So if you look, it says Mr. Branch KHS likes it. So join the club. 569 people like it. Alright. Do you guys all see that fine?
No.
Matt, or Mark, want to go back and hit the light? Sorry for calling you Matt. Okay. Is that better?
No.
No? Okay, or if you need to move closer, you can. Alright. Now, this grapher is good, but it's kind of finicky in how you put the equations in. The best way to put the equations in is to actually use this keypad right here to type in your equations. Don't use your keyboard. Okay? So I'm going to type that first equation in. 2x squared. 2x squared. And then it was plus. Oh, sorry, minus. Minus. Oh, too far. Delete. Minus 5x. Okay. Okay. If you look close, the first x is not bold. The second x is bold. So the way this is written is that an x that isn't bold is multiplied. An x that is bold is the x variable. So that's why it has two x's in there. It took me a little while to figure it out when I looked at it myself. Okay. I know, it's kind of, but it works well for graphing. Okay, now if I hit graph, there's our parabola. Now if I want to zoom out to see the whole thing, I can. Okay, see I'm zooming out, see the whole parabola. But I'm worried about where it crosses that axis, right? Right?
Yeah.
When we solved that equation, we got x values of 4 and negative 1.5. Now if I look at the graph, it crosses here. Here's 1, here's 2. That's right in the middle. So what do you think the x value is there? Negative 1.5. What's the x value here? 4. Isn't that kind of cool? I think it's kind of cool. All right. All right, Mark, want to hit the lights for me again? Thank you, Mark. Oh, nice guy. All right, now, the second equation we looked at was x squared plus 5x plus 3 equals 0, right? Right? Aaron, you can sit next to Matt if you want to. So we can see better.
No, I couldn't just see.
Okay. All right. Now, did we try to find the solutions to this? Did you guys try it?
Yeah.
Yeah. What'd you get?
No solution.
No. How do you know there's no solution?
Because there's no values of 3 that's on 5.
Okay, so there's no combinations of the factors of 3 and x that makes 5, right? Let's check to be sure. So what are the factors of x squared?
X and X.
X and x. Right? What are the factors of 3? 1 and 3. Right? Is there any way I can do x times 1
No.
plus x times 3 to give me 5?
No.
No, this always equals what? 4. Okay? Now, John said there's no solutions. Right? John said there's no solutions. So, no solutions. Now, I'll put a little question mark behind that because I don't know if I agree with him. Okay? No solutions means this parabola never crosses which axis? The x-axis. Okay? Now, you can try it on your calculators. Okay, you can see if this parabola ever crosses the x-axis. Or, we can try it on here. I think we can see it all right this time, Mark. Because this one's going to be in red. Or in blue, sorry. I can try to graph this on here. I'll do x squared plus 5x plus 3. So I just plugged it in. I'll go back to my graph. Now, the red one was the first one. The blue ones are next, is this one. Everybody see the blue one? Can you kind of see it? Now, with the red one, it crossed at a nice whole number of 4 and an easy to predict number of 1.5, right? Right? This blue one, does it cross those whole numbers? No, it doesn't, does it? So it's not that there's no solutions, it's just not factorable. Right? So this x squared plus 5x plus 3, there are solutions to it, but it's not factorable. Okay? So there are solutions, it's just not factorable. All right, why is it not factorable? We can't factor it into whole numbers, right? We can't find those whole numbers like we did in the first one that add to that middle term, can we? Okay. So, but there are solutions. We saw it did cross the x-axis, so there are solutions. So, to find those solutions, we got to learn a different way. Okay? It's not factorable. We need to find a different way. So, find solutions a different way. And this is the last part of this OYO. Right? We got to find solutions using a different way. That different way is called the quadratic formula. Okay? So, the quadratic formula for equations of the form 0 equals ax squared plus bx plus c, we can find solutions using the equation x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, we'll talk about the start points here in a second. All right. So, this is used for when?
When it's not factorable.
When it's not factorable. Okay, I would advise you, only use this when it's not factorable. Could we use it all other times? Yeah. This equation works every single time. Okay? For factorable quadratic problems, for non-factorable ones. Okay? But I need to caution you on tests when I say factor something, what do I want you to do? Factor it. And I want you to use the quadratic formula. Okay? On tests, when I say factor it, factor it. Okay? If I say find the solutions any way you want to, that means you can factor or use this formula. Okay? So, quadratic formula, use when we can't factor. Use when we can't factor. I think factoring is usually easier. Okay. You might think plug this in, get the answer out, that's easy. But it's easy to make mistakes with this big nasty equation because there's all this stuff in here. It's kind of confusing. Okay. Now, who's intimidated by that equation? Okay, good. Appreciate the honesty. Okay. Who's afraid they won't know how to remember that equation? Okay, we'll teach you a little way to remember that equation. Anybody know the Notre Dame fight song?
No.
Okay, I'm going to teach you the only good use for the Notre Dame fight song. Okay, if you've ever seen the movie Rudy, it goes 3 cheers for old Notre Dame. Wake up the echoes cheering her name. You guys remember that song? Familiar with that maybe? No? Okay, well, using the tune of that song, we can remember this formula. Okay, goes this way. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now we play a song. Okay, if you ever play a college football game, all right, if you ever play college football on Xbox or PS3,
Yeah.
all right, they play the fight songs. You can sing the quadratic formula next time.
Let's sing it together.
Okay, there's an easier version. I'll teach it together. Okay, I just like to get a little jab in Notre Dame. Okay, so the other way. Anybody remember the Pop Goes the Weasel song?
I do.
All around the mulberry bush, the monkey chased the weasel. You guys know that song? Okay, I don't know all the words, but I know it. At the pop goes the weasel. Okay. Another way you can remember this song is to that tune. Okay. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Singing all of the pop. The all at the top. You gotta make sure you hit the all, at the top.
Right, yeah.
Okay? So I'll sing it one more time and then I want us to get together, right? So x equals negative b plus or minus square root b squared minus 4ac all over 2a.
Are you still recording this?
I'm recording it.
Oh my god.
You can watch it later. All right. You guys want to sing it together?
Yes,
Okay.
yes, yes,
Okay,
yes.
ready? 1, 2, 3. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Nice job. Nice job. Yeah. Okay. So if you're having a hard time remembering that equation, then you can use Pop Goes the Weasel or the Notre Dame Fight song, both of which will help you remember that. Now I've posted some links on Facebook, Josh. Josh, I see you practicing. I posted some links on Facebook. Okay, one of them uses the Pop Goes the Weasel. It'll help you remember it. Okay. I posted another link of a guy who wrote his own Quadratic Formula song, so if you get a chance, you can watch that. All right. So this is the Quadratic Formula. We use this when we have equations that aren't factorable. Okay. Things you need to know. A is the number in front of what? X squared. B is the number in front of x. C is by itself. Okay. Now this only works when we're solving for when the equation equals 0. Okay. It only works if our equation equals 0. Okay. Now you're probably saying, well, this usually gives me 2 solutions, doesn't it? Right? Who's thinking that? This usually gives me 2 solutions. Okay. So you might be thinking that.
Yeah.
Okay. And then you look at an equation, you say, well, equations usually only give me one answer, right? But there's this part right here, this plus or minus.
Yeah.
Okay. One time we're going to have to do the equation with a plus there. One time we do the equation with a minus there. Right? So that's how we get our 2 solutions. Okay. So I'll do it with just a plus, get one solution. Do it with a minus, get the other solution. Okay. And then the last thing. If we look at this equation, there's one part of this where we can't plug every number, we can't use every type of number as an input, right? Right? Which part of this can't have every type of number being used? Nope. You're close though. Okay. This square root part, right? Can I square root negatives? No, we can't square root negatives, can we? So John said it has no solutions. There is a time where we'll have no solutions. And that's when this inside right here is negative. If b squared minus 4ac is less than 0, that means we have no solutions. Okay? That means our parabola either never crosses the x-axis and opens up, or opens down and never crosses the x-axis. All right? So once again, if your b squared minus 4ac ends up being negative, then you'll have no solutions. You guys are probably all excited to try this out, aren't you?
Yes.
Yeah? Okay, so we said that this problem right here was not factorable. Some of us even thought it had no solutions. Well, let's find the solutions. Instead of factoring, we're going to use the quadratic formula. So looking at this, what's my A? Ooh, not x squared. A is what's in front of the x squared. Aaron, what is it?
1.
1, good. So A is 1. What's my B?
5.
5. Okay, okay? Okay. What's my C?
3.
3. Okay. So now I know what A, B, and C are, right?
Yes.
So then I can sing the song to myself again. X equals negative B plus or minus square root B squared minus 4AC. Why does that catch up there? All over 2A. Okay. It's fun to sing the song.
It is.
Makes it exciting. Okay. So my B's are 5s, right? Right? My A's are 1. And my C was 3. So I just plugged it into the quadratic equation. Right? Now, Juan, I see you plugging that all in your calculator, aren't you? Okay. I'm going to caution you, don't do that. Okay? Because we have it all over one number, right? Right? This dividing part, that's where students make a lot of mistakes. Juan, you can do that as long as you put parentheses in the correct spot. If you put parentheses around the whole top, then it'll work out. Okay? But I'll caution you in just using your calculator because you might get an error in there. You might get an answer that you think is right, but your parentheses in the wrong spot, so it's actually wrong. All right? So let's try to whittle this down. Let's try to simplify this before we plug in our calculator. All right? So what parts of this can I simplify?
inside the,
The 4 and 1.
Inside the square root?
yeah,
Okay, what part do you think, Trey?
the 4 times 1 times 3.
Okay, what's 4 times 1 times 3?
12.
Yeah.
12, good. So we have a minus 12 in there. What else can I simplify? Doug?
The 5 squared.
5 squared, what's that?
25.
25. Anything else?
You can do the 2 and the 1.
The 2 and the 1. What's 2 times 1?
2.
2. So now I've taken kind of a big nasty problem, and I simplified it out a little bit, right?
Thank you.
Can I simplify this more?
Yeah.
Yeah, what can I do now?
Divide 25 by 5.
Ooh.
Subtract.
Subtract what?
25 and
Okay, subtract 25 and 12. Nice. 25 and 12 is what?
13.
13. So negative 5 plus or minus the square root of 13 over 2. Isn't this going to be a lot easier to do than trying to plug that whole thing in? No? I think so. Can we simplify this anymore?
Maybe.
Yeah. We can square root what?
13.
What's the square root of 13? 3.61. Okay. So this really equals negative 5 plus or minus this. Oh, not square root anymore. I get stuck in that song. Plus or minus 3.61 all over 2. Isn't this a lot easier to punch into our calculator than plugging that in? Juan, what do you think?
Yeah.
Yeah. Okay.
Why don't we put plus
So-
or minus in our calculator?
Good question. There is no plus or minus key, is there?
No.
No. So one of our x's is negative 5 plus 3.61 over 2.
Uh-huh.
The other x is negative 5 minus 3.61 over
Okay.
2. Now, if you want to, you can plug this all in your calculator, put parentheses on the top, put parentheses around the top. Okay? It will work now. Okay, as long as you put those parentheses in the correct spot. Or we can keep kind of simplifying. I like to simplify. So negative 5 plus 3.61 is 1.39 over 2. And negative 5 minus 3.61 is 8.61 negative
Negative.
over 2. And this one's a negative as well. So what does this top one get me? Anybody know?
Negative 0.695.
Negative 0.695. And what does this one equal?
Negative 4.305.
Negative 4.305. So, what does that tell me about this equation?
Across the x-axis.
Good. It crosses the x-axis at negative 0.695, right? And negative 4.035. Does that make sense? Does that make sense? You guys believe me that's where it crosses the axis?
Yeah.
Yeah? Okay, we can use this
Trace.
online grapher, and we can figure it out. So, the online grapher is, I think I showed it to you already. But if I move the mouse around, all right, it's kind of like the trace function on our calculator. Okay, but once again, it is an approximation. So right there, we're at about the x-axis, right? Tells me on the bottom of the screen that x is negative 0.7085. That's where it crosses the x-axis. Is that close to what we got?
Yeah.
Negative 0.695? It's close. Okay.
Real close.
Yep, I would take your equation though. Your equation's exact. The graph is a approximation. Okay, and the other spot where it crossed the x-axis was right here. Come on. All right, if you look down here, it says negative 4.28. We got negative 4.305. Close. All right. Once again, this is exact. The equation's exact. The graph is an approximation. Okay. Are there any questions about the quadratic formula? Once again, does it only work for non-factorable problems? No, it works for all. Okay, but if you can factor it, I'd factor it.